Welcome back. Today we're going to talk about probability. And when we're talking about probability, there's a couple of different types of problems that we're going to deal with. And I've given you a couple of examples here. And what we're looking at is how do I construct this problem so that I can solve it? Not just memorizing formulas, but how do I construct a problem-solving strategy in order to solve this problem and ones like it when I'm talking about dice or coins or whatever it happens to be. Thinking about the concept of probability as a whole. So these are the kind of questions that we're going to answer. I'm not going to specifically answer them right now. We'll talk about them more in class, but these are the types of problems that we're going to be looking at today. I want to start out by looking at probability in general. And the way that it's written in textbooks and the way that you've got to think about it to interpret that writing is very important. So the way that it's written in textbooks looks like this. They'll say something like this. P and then parentheses E, which means the P probability of an event E. And with the probability of an event E, it's equal to, and this is going to be a fraction, of the number of favorable outcomes over the number of total outcomes. So what does that mean? The number of favorable outcomes over the number of total outcomes. Well, basically it boils down to this. This is the number of ways to get what I want. For example, if I'm trying to roll a 7, if I'm rolling 2 dice, what are the ways to get 7? And on bottom is going to go the number of possible ways it could happen. Okay, the number of possible ways that it could happen. So the probability is the fraction of the ways to get what I want, the favorable outcomes, over what's possible. So let's look at the probability of rolling a sum divisible by 3 on a single roll of 2 fair dice. The best way to think about this would be to think about this in terms of two things. Die 1 and die 2. Because if we think about it in terms of, two white dice that we normally have, we encounter some problems thinking about, well, what if I roll a 2 and a 1? Is that the same as a 1 and a 2? So if you think about it, if these two fair dice are different colors. Okay, so there's a red one and a green one. What could happen on here is 1, 2, 3, 4, 5, or 6. But on the green one, I could also have 1, 2, 3, 4, 5, or 6. And what happens is if I roll a 1 on the red one, it could go with 1 on the green one, or 2, or 3, or 4, or 5, or 6. But I could also take the 2 and roll to 1, or 2, or 3, or 4, or 5, or 6. So any of the possibilities on the red one could go with any of the possibilities on the green one. And so this comes down to that problem solving and constructing the problem that I talk about often in our class. When we look at this, and I think about it in terms of two separate things. The first one is, what is possible? How many possible outcomes are there? Well, let's think just for a second. A sum divisible by 3, because I want the number of outcomes. So let's think about this for just a second. What's divisible by 3? Well, I first have to think, if I've got a set of dice, what could possibly be divisible by 3? If I roll a 3, so that'd be a 1 and a 2, or a 2 and a 1, that would be divisible by 3. Also 6, also 9, also 12. Can't go any higher because the highest it could have is 6 on each die, so 12 showing. So these are the possible totals that I could get on 2 dice. And the question is, how many ways are there to get those? And so I want to list out the ways. So thinking about this, any one could go with any other one. I've got to list out my possibilities. Well, I could have the case that I roll a 1 on the green die and a 2 on the red die, right? Or I could roll a 1 on the red die and a 2 on the green die. Are those the same thing? Well, if it was 2 white dice, it might seem so, even though it's not. But because I've got my red die and green die, you can obviously see that these are different events. So there's two things that could happen there. Well, what about for 6? I've got 5 and 1, 4 and 2, 3 and 3. So I could roll a 5 on the green, or a 4 on the green, or a 3 on the green, which would mean I'd roll a 1, or a 2, or a 3. But on the other hand, if I have the combination 5-1, I could also have the case where I rolled not a red 1, but a green 1, not a red 2, but a green 2, and not a red 3, but a green 3. Oh, wait. When it's doubles, it's the same either way. So I'm really considering two other cases. This case here and this case here. So notice, when I'm listing out my possibilities, I have to consider the fact that a 1-5 and a 5-1 are different because of the dice being different. What about a 9? Well, I could roll a 5 and a 4, or I could roll a 5 and a 4, right? And I could roll a 6-3 and a 3-6. So 6, 3, and I could roll a 6 with the red and a 3 on the green. Okay, so there's that possibility. And with the 12, what are the ways to do it? Let me think here. So I could roll a 6 green and a 6 red. But those are the same, whether you switch them around, because if I've got the 6 on the green and 6 on the red, it's the same. And so how many ways is really what I'm considering, because the probability of my event is the number of favorable outcomes, which is equal to the number of ways divisible by 3, which is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 favorable outcomes. So there's 12 ways to roll something that's divisible by 3. But the tricky part of this one can be, what about the possibles? What about the possible outcomes? That's where we're coming back here, okay? And so I illustrated that to say, you know, the red one and the green one are different. But every single event on the red die, there are 6 of them. And every single one of them could go with every single one of the green ones, which is 6 different ones. And so my number of total outcomes is 36. Or 1/3. There's a 1/3 probability that I roll something that's divisible by 3. I could also express this as a percent, 33.3%. 0.3 repeating percent. Okay? Which brings us to our next note, the probability function. The probability function is basically putting the numbers with probability. The probability of any event has to be between 0 and 1. 0 equals not going to happen. I will never be drafted into the NBA. Not going to happen. Not nearly athletic enough. Never going to happen. Okay? 1 is definitely will happen. Okay? So 0 is 0%, 1 is 100%, because the sum of all events, sum of probabilities, of all possibilities is 1. For example, if I roll a dice, well, really just a die, to get the number 1, there's a 1/6 chance. To get the number 2, there's a 1/6 chance. To get the number 3, there's a 1/6 chance. To get the number 4, there's a 1/6 chance. To get the number 5, there's a 1/6 chance. To get the number 6, there's a 1/6 chance. I think you see where I'm going with this. There's 6 possibilities. Each of them has the probability of 1/6. So 6 times 1/6 is equal to 1. There's a 100% possibility that something is going to happen. Okay? We talk about that to mention this. When we do problems, there's a couple of different ways, but it has to make sense. In this problem, we're going to talk about chocolates, picking chocolates out of a box where we don't know. We've all been there. You don't want to get the coconut one. One time I bit into one, I was sure it wasn't coconut because I'd already bit into the coconut one, and it was an orange cream. Didn't know how I felt about that. But we've all been there where you don't know which one it is. And so what's the probability? Sal opens a box of a dozen chocolate-covered creams and generously offers 2 of them to Val. Val likes vanilla creams the best, but all the chocolates look alike on the outside. If 4 of the 12 creams are vanilla, what's the probability that both of her picks turn out to be vanilla? So the probability of the event is number of both turn out to be vanilla. Number of ways both are vanilla over the number of ways what? What's for sure going to happen? Well, for sure he's giving her 2. The favorable outcome is 2 vanillas. So the number of ways to pick 2 chocolates. It's not technically chocolates, they have vanilla cream in them. Chocolate covered creams. Maybe they are, I don't know. And so we think about this problem in 2 ways. Let's talk about the first one. The number of ways that they are both vanilla. So you have to consider this event. So I've got these chocolates here. What are the ways to pick 2 vanillas? Well, how many vanillas are there? 4 of the 12 creams are vanilla. So there's 4 vanillas, and we want to pick 2 of them. Why combination? Well, if I have 4 chocolates here, think about it. 1, 2, 3, 4. I'm not ranking them. If these are the 4 vanillas, if I get 1 and 2 and he hands me 1 and then 2, and I have 2 and then 1, it doesn't matter. I still have those 2. So I could either pick these 2 or these 2 or these 2, or I could pick these 2 or these 2 or these 2. So 1, 2, 3, 4, 5, 6. 4C2 combined 2 is actually 6. That's the number of favorable outcomes. Well, Mr. Saris, why is it 4C2? Why does it have to do with the total number? I'm thinking about the favorable outcomes, meaning picking 2 vanillas. How many ways are there to pick 2 vanillas? Well, of the 6 vanillas, you know you're picking 2 of them. Or sorry, of the 4 vanillas, you know you're picking 2 of them. But the number of ways are to pick 2 chocolate-covered creams is 12 combined 2 at a time. Why? Because I'm not concerned with what they are. I'm saying how many total outcomes are there? How many ways could I pick 2? So I could have chocolate and vanilla, vanilla and chocolate. 1, 2, 3, 4, whatever it is. I need 12 of them. I'm combining them 2 at a time. And when I do that, that's 66. And so I have a 1 in 11 chance of Sal has a 1 in 11 chance of giving Val 2 vanillas. That's one way to think about it. Total number of favorable outcomes over total number of outcomes. Maybe that doesn't make sense to you. Maybe you're a person who thinks like me in some ways, and you think about this as 2 events. Sal is physically going to hand her 2 chocolates. Well, we're going to assume that it happens the way that it needs to happen, 2 vanillas. In the first chance, when he reaches into the box, what's the chance that one of them is vanilla? It's a 4 out of 12 chance. And we're going to assume that the first one is a vanilla one, and for sure we're not putting it back in because she's already eaten that one, whatever. How many ways are there to pick a second vanilla? Well, there's 3 vanillas left because we definitely handed her 1 out of 11. And when we do this, we get 12 out of 132, which reduces down to 6 out of 66, which is 111. Okay, so which one's easier? I don't know. I don't know what it looks like for you. There are merits to both. In the first event, we consider the total number of outcomes. We consider the total number of favorable outcomes. It's a way to think about it. In the second way, we think about the actual event of reaching into the chocolate box and seeing, well, what could possibly happen in the first one and multiplying it by every possibility in the second one. Like I said, I don't know what works for you. They both for sure work in this case. Okay? So thanks for watching, guys. We'll pick up there. We're going to finish the rest of the notes tomorrow. But thanks for watching, and we'll see you next time.